Welcome back to our session. Today we will see how to manipulate different data sets and how to convert a data set to its long form and also in short form, creating a new variable and create contingency table, and finally we'll see how to conduct a chi-square test. We'll also use these data sets. Actually, these two data sets are the same, so in different formats we can present this data. First, we will read this data set using a R script. First, we see that its data set starting cell is P7 and the ending is T11. So P7 to T11 actually these data sets. Let's go to the R. Okay, so first we need to set our working directory. Set our working directory to the location that we want. So we are setting this to R course MS PhD. This is our working directory. So here we will open a new R script and new R script. Its title is data manipulation. Its title is data manipulation. Do not remove this .r, otherwise our program cannot recognize. So this script is created with data manipulation R. So this directory we want to make as working directory too. So we need to click this set as working directory here. So it has correctly set. Now we'll read the data set. For doing this analysis, we will need two R packages. One is R core plot and another is tidyverse. If you do not have these two libraries installed, you can install using tools, install packages. Then you can type the package name here, core plot, and hit the install button, and it will install this package to your system. So this is a comment. Lesson 4. We are commenting out this so that R does not recognize this as a command. Now we will read the data set. Data set is starting from P7 to T11 and its sheet name is wrangling. Data set name is data sets. So we need all this information to read this data set. So we are going back to our R program. And reading this data set. Now we see the data. How does it look like? If you want to see, we need to call these data sets. We see that our data has been read correctly by the program. So now we'll add a variable named total here. By adding all this value, we will create one new variable. So this we will use this tidyverse package. We need to load these two packages before running this command, otherwise this muted function will not work, because this muted function actually comes from this package dplyr. Because tidyverse package contains all this package. So We are using the original data set here, data, and this is called piping operator. Piping operator means the previous object will be used as input for the next commands. So this data set will be used as input, and we will mutate the variable. These three variables will be added together to create a new variable total, and the whole object we will store in data1. Then we'll call this data1. See how does it look like. We see that the total column has been created. Now we want to create another variable here, cumulative frequency, where 79 will be the first value, then 79 plus 37 will be here, then adding all these values will be here, and adding all these values will be placed here. This way we will create one cumulative frequency. Here we have used one bracket here, and we have closed with another bracket to store the value in data2, but we want to also show what this object contains. So this data2 actually comes from data1, and we are mutating one variable sum total. Actually, this is a function cumulative sum. That means this total column will be added one after another to form this cumulative frequency column. Let's run this, and we'll see another variable named CumFrequency. CumFreq has created, the first value is 79, then 79 plus 37 is 116. 116 plus 55 is 171, plus 44 is 215. So cumulative frequency column. So from using this data set, we will create one pareto chart. One pareto chart we will create. For pareto chart actually shows two things. One is bar for SSC 37, Bachelor 55, bar chart integrated with a line with the cumulative frequency. So for this, you can use ggplot function. ggplot function, we are taking this data set 1. If we take data set 1, we will see that creating the pareto chart, we want to change the order of the bars so that the bars remain SSC, Bachelor and Masters, so that we can see the bars in this sequence. Now we will plot the pareto chart. For pareto chart, we will need this command. The ggplot, we are using data2 as our input, and its aesthetic is here. Aesthetic means we will plot education along the x-axis, total along the y-axis. Total means or total frequency 79, 37 days, and the color and field color will be different based on the education level. And this geom call means a bar chart will be created. Then the line geometric shape means cumulative frequency will be plotted along the y-axis. Group 1 means there will be only one line based on the cumulative frequency, and its size means the line width will be 2 point. Then we need to include one secondary axis. The primary axis name is frequency and the secondary axis name is cumulative frequency. Secondary axis will be created based on this transformation. We are not transforming any value. We can transform the primary variable by specifying here different formula like 10 times or divided by 10, or straightforward we can transform, but we are not transforming here. This is the function secondary axis. Then we are also labeling the different values and their position. We will see one by one how does it look like. First, let's see the plots. So this is the plot we have drawn. This is the Pareto chart, and here y-axis shows the frequency and x-axis shows the different levels of education. There is the secondary axis. It shows the cumulative frequency. This is the cumulative frequency curve. This is the bar chart. So both of these elements constitute the Pareto chart. If you want to see the functions of these different levels, we need this, or we can just run one by one. If we run only this part, it will show only one canvas. It will draw nothing because only data set it has taken. Later on, when we add this aesthetic, it will show that the y-axis takes education, and x-axis takes education, and y-axis takes total as the variable. If we draw this geom call, now it has drawn the columns. So if we want to add the cumulative frequency as the line, and we can run this part. It has drawn the line. Now we need to draw a secondary axis here. So we are drawing secondary axis with this plot. Secondary axis has been drawn, and the geom text means we want to put levels here. So put levels here. We are running this to put levels. You see 79, 37. So the value of SSC, HS, and different levels of education are put on the top of this bar. Here we have put that Y means the place of the level, total plus 10. If we delete this, we'll see that the levels will be here. So it's overlapping with the bar. That's why we have written plus 10. That means this value will go up by 10 based on this frequency. Later on, we have also put values here. The cumulative frequency value we put here, it gives this type of graph. We want to remove the background shading color by this theme black and white. Also, we do not need this legend, so we are putting the legend position equals none inside the theme. So now if we run this full command, it will give us this nice graph. If you want to change these values to %, can you do this? In this case, we need to convert the values to %, and we are naming the data set as data 3. We are taking this data 2 as our input. We are mutating the total variable using the previous total variable multiplied by 100 and divided by sum of total. That means total of total. And cumulative frequency also we are summing over all the total divided by cumulative frequency. If we run this, we see that our total and the cumulative frequency column has changed to %. Now we want to create the graph again using the dataset 3. Now if we run this ggplot command, we see that this graph, but here you see the percentage takes long digits after the decimal points. If you want to change this decimal point to 2 digits after the decimal, you need to round this figure. There is one small command here. If you run this command, then it will change the digits up to decimal points. So we are mutating the total based on their round. Round means we are rounding the values up to decimal points. Cumulative frequency, we are rounding the values up to 2 decimal points. If we run this command and then run this ggplot, we will have this plot. Now go back to the original data set. What we want to do, let's have a look on the original data set. We want to change this data set to a long table. Long table means there will be 2 variables. One is education, another is for sports. Third column will contain the values. So here SSC will have football, 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 football. The HSC will have football, football, different sports, and the right column will contain their frequency. So to change this, we will use pivot longer command. Pivot longer column. Now our data set has changed to education, sport, and their frequency. You see that SSC football was 34, SSC football was 34, SSC hockey was 25. So all the sports name have formed a column in their original frequencies. So we have named this data set as long table, and we have used this pivot longer command here. Data is our input, the original data set. The columns that we have selected to make this long table, football to baseball, it means all these columns are selected for transformation. So this column means the range starting from football through baseball. Names to means where will these football to baseball column names will go. This will go under the sport variable. That's why we have specified the name of the variable, and the values to where will go this frequency. We have written the name of this variable as frequency. So in this way, we can convert this wide table to a long table. We can again change this table back to this type of short table. Short table. If you want to make the short table from this long table, we will use this pivot wider command. Here we used pivot longer function. Here we are using pivot wider function. So names from, now we will take the names from, means this export variable, we will take the column names. Values we will take from the frequency, this frequency. That's why this table will be wide and it will look like this. So these names came from the export variable, and these are the values have come from the frequency column. This the data set is still, but we want to perform chi-square test on this table. So this is not straightforward. If you give command of chi-square test, it will show you error. That's why we need to convert this table to a contingency table. Contingency table does not have this variable name. Actually, these will be used as row names. That's why we need to change this education column as row names. For that, we will take the short table as our input. We are renaming the object as contingency table, that means cont table. Here column to row names. This column, this variable education, will be used as row names. So this education we will not see. If we use this cont table, you see these are the row names, not a variable name called education. This is only the row names. Now we can use the chi-square command. Chi-square command. Chi-square. This is the function, and this table is our input. And the results are saved in the chi-square object. Here we see the chi-square result. We will see the p-value is very small because 7.9 times 10 to the power minus 8. So this point actually 8 digits to the left. So this is very small. So as the p-value is less than 0.05, we can say that p-value is very small. When p-value is small, it cannot support the null hypothesis. So we need to reject the null hypothesis. Our null hypothesis actually was there is no association between education and sports. That means the sports do not vary with the education levels. As this hypothesis is rejected, it indicates that preference to different sports actually depend on different levels of education. We can explore different values saved in the chi-square. It's a list, so it contains expected values. It also contains the observed value, that is our actual value here. So from this actual value, the expected values are computed. This is actually the row sums and column sums multiplied, then divide by the observed value, then you will have this value. If you divide the column sums and the row sums, multiplied, then divide the multiplication by this 25, you will see this 23. Here you can see the formula. So the expected frequency means row sum multiplied column sum divided by grand total. Grand total. So I was wrong actually. So our grand total is, if you add all this value, then you will see grand total. And row sums multiplied column sums. If you want to calculate the expected frequency for these cells, you need to calculate the row sums, also this column sums. Then you need to multiply these two sums divided by the grand total, not divided by this 18, divided by the grand total. You will see the expected values. Then from this expected and observed value, you can calculate the residuals. The formula of residual is observed value minus expected value divided by square root of expected value. So this is the formula. Residuals. Now we see that our p-value is significant. So which cells actually contributed to this chi-square value? We can just analyze these residuals. If the residuals are greater compared to the 0, then these cells contributed most, either negatively or positively. So we can visualize these residuals, these chi-square residuals, using the plot function. But this is not correlation value. That's why we are using is core false. These are just some options. Even if we do not use this, still we will have this plot. So we're making it larger. You see the plot is here. The other elements we need to make the title color blue. So this color will be blue, and the legend position, this legend color legend position will be placed in the bottom. This plot will have a title, size of the residuals, and this is the margin. The margin will be increased. So this is the furnished plot. If we do 0 here, you see the title goes outside the margin. That's why the top margin we have increased. This margin sequence, this is bottom margin, this is left margin, this is top margin, this is right margin. In the same way, we can calculate the contribution. This, because this is mixed with negative numbers and positive numbers, we can calculate the contribution of each cell to the chi-square by removing this minus sign, negative sign. So this is the formula, the residual square divided by the expected value. This will give you the contribution. Here you can see that the formula of contribution, residual square divided by chi-square value. Divided by chi-square value, not so chi-square. Let's see here. Statistics. Actually, here will be statistics, not the not the expected value, because it says that The numerator will be chi-square value contribution. So we are plotting this. So we have wrongly typed here. So we are running this. Now we are plotting this core plot. Now you will see that which cells contributed more, and its value you will see that 0.38. That means you can also convert this to percent. Percent contribution will be multiply 100 percent contribution. Actually percent sign we cannot give here, that's why it shows error. So we are converting this to percent. See that now it's 38%, and here is 0.09%, the lowest value. The smaller the dots and lighter the color, the smaller contribution to the chi-square. Darker the cell and darker the color, it will indicate the highest degree of contribution. In our previous plot, if we see the residual plot, it has negative. That means negative means our observed value is less than the expected value. Here the bluish circle means our observed value is higher than the expected. If all the values were similar to the expected value, the observed value equal expected value, then these values would not be significant. Is that they are different from the expected values. That's why these cells contributed to the chi-square value become significant. Another data set we want to transform in this lesson. Let's go back to our data set. We will read this data set starting from G18 and ended to I298. It's in the chi-square sheet of the data sets Excel SX data. We're going back for R. Now we will read this data set and check its structure. It's a long data set, that's why we only check its head and tail. Its head and tail. Head is 1 SSC football, 6 is football, 275, 280. We see the data set, we see the 280 up to. So this data set has read perfectly. Now what we want to do, we want to transform this table to a contingency table. Contingency table. So we are giving the object name cont table. We are using its simple function table, and we are taking this education column, and the sport column to the 2-dimension table. You see this sports column from the column heads and the education levels from the row heads. Now we can convert this table, because actually this is not a data frame. If you see the class of cont table, oops, it says it's table, it's not a data frame. So we want to convert this data frame For that, we need to use this as data frame function and use this quantity table as its input. So now if you check this class of count table data, it will show it's a data frame. As it is a data frame, we can see how it looks like this count data. Just select this and run. It has three variables: variable 1, variable 2, variable 3. We can rename these column names. Now if you see the count data, this is the column names are changed: sports, education, sports, and frequency. So these column names have changed. We want to create one new variable named serial number. How will you do? Because we first add row names, 1 to number of row. We know that number of row in our count data 16. We run this part to 16. So we are adding row names. Now you see the count data. So its row names has been added. Now you want to change this row names to a variable named SR. So we are taking this count data as our input. We are running this and see the data. So this actually has changed the SR. We don't need this. So this actually has changed the row names as SR variable. So this is all, and thank you very much, and see you in the next session.
Ruin Research, a team for smart planet equipped with smart research tools, smart research ideas, and smart research culture towards smart development.